Hello, the video today is an example of a three-dimensional lesson in science class. Admittedly, the lesson is weak on the engineering aspect, yet I believe it is still important to think about each of the three dimensions, the disciplinary core idea, the science and engineering practice, and the cross-cutting concept as you plan lessons for your science classes. So recently, my students in class made borax um, ornaments. So we took a pipe cleaner, and they shaped it however they wished. And then we took a cup or a jar and we put some hot water in the jar and added some borax to it. Students mixed up the borax and then dipped in their pipe cleaner. The pipe cleaner, we let it set undisturbed for a few days, and the students had crystals form on their pipe cleaner. Oh, God dang. Over the past month, students made borax ornaments. In order to do that, we took some hot water and borax, mixed it up in a cup, and students fashioned an ornament out of a pipe cleaner. They used whatever design they wished. It just had to be able to fit in the cup. And they added their ornaments to the cup, let it sit for a few days, and then they were pleasantly surprised when they saw all the lovely crystals grow on their pipe cleaners. Now, in general, this is just an activity, but we can change that activity to use each of the dimensions of science. So after students made their borax ornaments, which is an example of a physical change, they were asked to create a model of how the crystals were made. Now, students, of course, would want to just show what they were able to see, but I had them focus in on what is unseen. What is going on that we cannot see that's causing these crystals to form? Once students had made their initial model, and mind you, in this model also we had just the borax in the water. The students then had to do the model of how the borax entered the water to make a solution or a mixture, and then the students had to model how the crystals were made. So they had 3 frames to their model. But once we were done with that, then we were prepared to do some reading and some discussion in class because students had already thought through these ideas. Then of course they're interested in seeing if they're correct or incorrect. So they're more engaged in class discussion, especially when they know that we are going to go back and be given an opportunity to revise these models. But then on top of that, they had to write an explanation for what was going on. So we did a very visual way of trying to explain what goes on, and then we did a written way of explaining what goes on. So the disciplinary core idea I listed for the lesson across the top here, the fact that matter is composed of atoms and molecules can be used to explain the properties of substances, diversity of materials, states of matter, changes, and conservation of matter. Did we touch on all these parts? No, but we were working with this disciplinary core idea while we were working on this activity. The modeling part is the science and engineering practice of developing and using models. So students have models similar to this. Notice that we use a little bit of a call out because this indicates that we took this tiny little spot here on that cup of borax solution and we've made it bigger. We've magnified it. It's like we put it under a microscope because often students will see pictures of solutions with only like 10 molecules or 10 particles being represented, and that's not accurate in any shape or form. So we started to use these call outs so students realize it's just a small little area that we're magnifying, that there's actually a whole lot. So they build the idea of atoms and molecules are really small, and there is a lot of them, and almost an infinite amount for our ability to understand. Once we have that, and also notice that we had some sort of way of marking whether it was hot or cold because our system here, we would refer to this as a system. We would talk about whether the temperature of the system was high or low because that's important to understand as to why these crystals are being formed. Last, the cross-cutting concepts. So once again, we mentioned that there was a system, and we made a model of the system in terms of talking about inputs and outputs. We also talked structure and function because the crystals initially, if you ever look at 20 mule team borax, the crystals, how they look there and how these crystals look, they do look different, and we discussed what is going on in terms of the structure and how those better crystals are being made. Last but not least, we do have some stability and change going on. So as the solution cools, its ability to hold that extra borax um, disappears as well, so to speak. And so this system has to have a change go on because the water can no longer hold all the borax that's dissolved in it. So where does it go? It goes to these pipe cleaners in the form of these nice crystals. We also discussed how we had to leave them undisturbed in order to be able to allow the system to form nice big crystals that if we were constantly disrupting it, we wouldn't get the nice crystals we had today. So notice how we changed an activity that is for fun in the kids' minds, and we allow them to have that experience with it first, and then we work on discussing and sense making afterward in terms of kids had to describe what's going on, why it happened. Once we're done with that, we can give a formative assessment of probe, such as this one, and see how well kids have understood these ideas and how they are able to take these ideas and apply them into a new situation that is very similar. We still have a solution that we're talking about here, but it's even going to be a little more familiar in terms of sugar water.